Welcome to Lesson 1, Simplifying Radicals. This is the first lesson of Unit 8. So this is kind of a review from Algebra 1. So squares and perfect squares. I have these labeled here as squares. When we square them, we get down here. These are our original numbers, our original integers, and what we're going to do is when we square them, we get these numbers here. And these numbers are our perfect squares. Perfect squares are nice because whenever you take the square root of them, you get back to their integer form. You get a nice whole number. If it's not a perfect square and you take the square root, then you get a decimal. And we don't want to work with the decimal, we'd rather keep it as a square root. So if you see any of these right here under a square root, it's nice because you can just say, okay, I know that the square root of 36 is 6. So what happens when we square root? Number 1, here we have the square root of 3. Well, I'm going to square it. And squaring a square root is like addition, subtraction, multiplication, division. They're like opposites of each other, so they're going to cancel each other out. So if you square a square root, the square and the square root essentially disappear, and all you're left with is what's ever underneath your square root. Same thing over here with the square root of 30. We square it, and we're left with 30. Now I'm going to show you two methods for simplification. This is the one that I show you in Algebra 1, our factor tree and circle method. What we do is we just look at whatever we have underneath our square root, and then we factor it all the way down to its prime. So I see 50, so I know 5 and 10. 5's prime, so I can't factor it. 10 factors down to 5 and 2, and I can't break it down any further. After I can't break it down any further, I'm going to mark out everything that's not a prime number because I don't work with it anymore. And then I'm going to circle all the pairs that I have. So right here I have a pair of 5s, and I don't have anything to pair that 2 up with. So after you have circled all your pairs, what you do is anything that is in a circle, anything that's paired up, you're going to take one of those outside of the square root. So we have a pair of 5s, so we're going to take out 1 5. We don't have any more pairs, so everything else goes underneath the square root. So we're just left with a 2. So the square root of 50 simplifies to 5 square root 2. Let's try another example. Let's try the square root of 48. Okay, I know 4 will go in it 12 times. I can break down 4 into 2 and 2. I can break down 12 into 4 and 3. And I can break this 4 down to 2 and 2. So now anything that has a tree coming out of it is not prime, so I'm going to mark it out. And then I'm going to circle my pairs. So I have a pair of 2s, so I'm going to pull out 1 2. I have another pair of 2s, so I'm going to pull out another 2. Now I just can't pull out 2 2s. There has to be an operation that goes on. And that operation is multiplication. Everything else is going to go underneath the square root, and it's a 3. And if you have more numbers that need to go underneath the square root, you would multiply in the same way, like we did on the outside. So we simplify. 2 times 2 is 4. 4 square root 3. So I want you to now to go ahead and pause the video and work through these in your group. Do that now. So here are all the solutions to those 4 examples. So go ahead and pause the video again and check with your group to see if you got the correct answer. Now, I want you to realize that there are multiple ways to actually get to your final answer for some of these problems. They're not all done the same exact way. So if you work it a different way but get the same answer as your people in your group, that's alright. Okay? The second method for simplification is I call it factoring by the biggest perfect square. What you're going to do is you are going to look at whatever it is and you're going to find the biggest perfect square that goes into it. As in, we'll divide it. So your 1, 4, 9, 16, 25, that's what we're looking to see can go in there. So we look at 50, and I know that the biggest perfect square is 25. Now the trick to this is to look at the number and divide it by 2. So you take 50, divide it by 2, and you get 25. Now it works out because this 25 is a perfect square. I'll show you one in a second where it doesn't really work. So get rid of that. So I know, break it down to 25 and 2. What you're going to do now is you're going to take the square root of both and multiply that together times the square root of 2. Now we know the square root of 25 is 5. The square root of 2 is just square root 2. Okay, now let's try it with the square root of 24. What we're going to do is we're going to do 24 divided by 2, and that gives us 12. Now, if this number right here isn't a perfect square, what you do is you look at all the perfect squares below this number to see if they will work. So the next biggest is 9, and then it's 4, and then 1. Well, we look at 24. You can't divide 24 by 9, so that doesn't work. But you can divide 24 by 4. So we divide it by 4, and we get 6. So we take the square root of 4 times the square root of 6, and we get 2 square root 6. So that is the second method for you to use whenever you simplify radicals. So I want you to go ahead, pause this video again, and work through these in your group. And here are the answers to these 4 examples, so go ahead and pause the video again and check your answers. Alright, now we're going to talk about addition and subtraction of radicals. Adding and subtracting radicals is just like when we add and subtracted with variables. You have to have the same variable to add them together. The same thing with radicals. You have to have the same number underneath the square root. So if we look at example 1, we see that we have a square root of 2 and a square root of 2. So we can add the numbers in front. And we only add the numbers in front. We do not add any of the numbers under the square root. So 3 plus 5 is 8, square root 2. Now I'm going to jump down here to number 3. We see here that we have 2 square root 3 and 3 square root 12. Sometimes you may have to simplify a radical before you can add or subtract. We know we can simplify the square root of 12. It becomes 4 and 3. So this becomes 3 times 2 square root 3. So this becomes 6 square root 3. So we're going to rewrite this with 6 square root 3 in place of our 3 root 12. So 2 root 3 plus 6 square root 3 you can see now we can add. And we get 8 square root 3. So now I want you to pause the video again and do examples 2 and 4. And here are the answers for 2 and 4, so go ahead and pause the video again and see that if you got the right answer or not. And if you didn't, confer with your group to find out why. Okay, next we're going to talk about multiplying radicals. And multiplying radicals is actually easier than when we add or subtract them. When you multiply radicals, you multiply whatever's on the outside together, whatever's on the inside together. So what we have on the outside for number 1 is a 1 and a 1, which means we have a 1 left over, which we don't have to write. What we have underneath the radical is 2 times 5, which is 10. And your last step after doing this is to see if you can simplify what's under the radical even more, which here we can't, so we're done. Our answer is just square root 10. So go ahead, pause the video, and work through 2, 3, and 4 with your group. And here are the answers to 2, 3, and 4, so go ahead and pause the video again and see if you got them right. If you did not, please talk with your group about why. Okay, last, dividing radicals, or what we're going to call rationalizing. You cannot have a radical square root on the denominator of a fraction. So we have to move it. We can't change what the fraction is, but we can change the way it looks. We need to multiply by something that will change the way it looks, but without changing what it is. And there's a number that does that. It's 1. But multiplying by just 1 is not going to really change it. We have to multiply by something that's the same thing as 1. To give you an idea, 1's the same thing as 2 over 2, which is equal to 3 over 3. So if you notice, if we put the same thing on the numerator and denominator of a fraction, it's still 1. So that's basically what we're going to do, except we're going to do it with what we want to get rid of. We want to get rid of a square root 3. So we're going to multiply the numerator and the denominator by square root 3. You just multiply across. 2 times square root 3 is 2 root 3. The square root of 3 times the square root of 3 is just 3. So we get 2 root 3 over 3. And we can't have radicals on the numerator of our fraction. So I want you to now go ahead and pause the video once again, work through these last 3 examples with your group. And here are the answers to 2, 3, and 4. So go ahead and pause the video again, check with your answers, check with your group to see if you got these right, and if not, why. And then this is the end of the video.